Hello everyone. The title of this video is Using Long Division to Divide Polynomials. So each example I'm going to be taking for this video is taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 5.4, called Dividing Polynomials, and I'm under the heading Using long division to divide polynomials. Alright, so each example I'm going to do is either going to be one of the examples from the reading or one of the try it problems from the reading or one of the exercises at the end of the section that's related to this particular objective. Okay, so they go through an example of how to do long division with integers, with whole numbers here. Just kind of refresh your memory and write out a bunch of stuff. There's a lot of stuff for you to read and examples to see, but I just want to get down to the how-to, and I'll write a bunch of stuff for you as we go through certain examples. Alright, so here's the steps I'm going to follow. Given a polynomial, and now I don't know why they're doing a binomial. Really, this is for any two polynomials. Here's how you use long division to divide the polynomials. So 1, set up the division problem, which I'll show you. 2, determine the first term of the quotient by dividing the leading term of the dividend by the leading term of the divisor. 3, multiply the answer by the divisor and write it below the like terms of the dividend. 4, subtract the bottom. Again, don't worry about it. Shouldn't have to be a binomial. Really, this works for any polynomial divided by any other polynomial. Right. Bring down the next term of the dividend. Repeat steps 2 through 5 until reaching the last term of the dividend. And if the remainder is non-zero, express as a fraction. Okay. So again, I'm going to be going through these same steps for every single example in this video. And I'll write out, little notes on what I'm doing as we go through. Alright, so my first example, again, we're asked to use long division to divide the polynomials. Alright, so we're asked to divide, this degree 3 polynomial, 16x cubed minus 12x squared plus 20x minus 3, divided by 4x plus 5. Right. Now the polynomial that you're dividing into, so this degree 3 polynomial here, this is called the dividend. It's called the dividend. The polynomial that you're dividing by is called the divisor. Now, an alternate way to write this is as a fraction. Whenever you see a fraction, that's really just another way to express division. The dividend is the numerator of that fraction. So we have 16x cubed minus 12x squared plus 20x minus 3 divided by a big fraction bar here, and then the divisor would also be the denominator, 4x plus 5. Right, or another way to express division, instead of writing it in words or as a fraction, is with the division symbol. Right, you take the dividend and then divided by, right, the division symbol right here, little line with a dot above and below it, and then the divisor. Okay, so far all three of these things mean the same thing. They're all talking about dividing the same two polynomials. But the one we're going to use, or, is the long division symbol, right? This, and again, I'm hoping you know how to divide numbers at least using long division. That was this symbol here. It looks like a square root symbol, but a little curlier. So here's the long division symbol. And then how this works, right, is the dividend, right, or the numerator of your fraction goes underneath the symbol. So once again, the word dividend. And I would recommend putting it in general form for a polynomial, right? Descending order. So we have 16x cubed, right? Then the minus 12x squared term, then the positive 20x term, and then the negative 3 term. Again, put it in descending order. And the same thing goes for the divisor. Right? Now the divisor goes on the left side of the symbol, right before the curl, what you're dividing by. Okay, so that'd be 4x plus 5. And again, it doesn't, in the book it says you're dividing by a binomial, something with two terms. This procedure I'm going to show you works whether you're dividing by a binomial or a trinomial or really any polynomial. Okay, so this was the step one, the set up the division, right, with the long division symbol, and put the dividend inside, divisor outside in descending order. Okay, now for the steps. Now I'm going to kind of shorten the steps a little bit here. First step is to divide the lead terms. Only the lead terms. Okay. So the dividend's lead term is 16x cubed. And we're going to divide this by the divisor's leading term, which is 4x. And then you do some cancellation here. 16 divided by 4 is 4. X cubed divided by x to the first would be x squared. This goes in the area up top where the quotient is going to be. You may recall that the quotient is how many times the divisor goes into the dividend when you did long division with numbers. So this 4x squared I'm writing up here. And again, this area above is where the quotient is going. All right, so that's the first term of the quotient, 4x squared. So you have a division step where you divide the lead terms. Then you multiply by the divisor. Let me show you what I mean. So there's a division step, then a multiplication step. Right, this multiplication step looks like this. You take the term you just wrote after the division step, just that term, and you multiply by the divisor. What's 4x squared times the quantity of the entire divisor, 4x plus 5. And that is, and you just write that in the next line after the dividend, right below the dividend. And they suggest, and I suggest this as well, line up like terms. 4x squared times 4x would be 16x cubed. So I'll put that underneath the x cubed term from the dividend. And then 4x squared times 5 would be 20x squared, positive 20x squared. Okay, so next, and again, these are the same steps really when you did long division with numbers. It's the same steps. You had a division, multiplication, then a subtraction step. Subtract. All right, now, don't just subtract the first term. You subtract this entire result. So notice I'm putting parentheses here. All right. You're going to be distributing this minus sign. So just again combining like terms. You got 16x cubed minus 16x cubed. That's nothing. All right, so I'm not writing anything here. Then for the x squareds, negative 12x squared minus 20x squared. You're subtracting every term from the line above it. Negative 12x squared minus 20x squared would be negative 32x squared. And then you have 20x minus nothing would be positive 20x again. Then negative 3 minus nothing would be negative 3 again. Right? So basically, the terms that aren't being, don't have anything to subtract away from, just get dropped down. Right? But you are just subtracting the line you just wrote from the previous line. All right, then you just repeat. You repeat these steps: the division step, the multiplication step, the subtraction step. Repeat until the degree after the subtraction step is less than the degree of the divisor. The divisor is a degree 1 polynomial. This polynomial here after subtraction is a degree 2. So I must keep going. So repeat until the degree after subtraction is less than the degree of the divisor. Okay, and these are the steps the way I'm writing them. Okay, so then we start over. All right, because again, the degree, this is degree 2, the divisor is degree 1. That means we're not finished. So I start over and do the division step. We divide the lead terms. What's negative 32x squared divided by 4x? That would be negative 8x. And that means, negative 8x is the next term I'm writing in the quotient. Negative 32x squared divided by 4x is negative 8x. And then I do the multiplication step. Take just the negative 8x, just the term I just wrote, and multiply by the divisor. Negative 8x times 4x is negative 32x squared. writing that below the other x squared. And then negative 8x times positive 5 is negative 40x, and I'm writing that under the x term. So I've done the division step, divide the lead terms. I've done the multiplication step, divide that term in the quotient I just wrote by the divisor, write the result in the line below. Now the subtraction step, I put a big minus sign and then parentheses around that line we just wrote, subtracting every single one of these, distributing the negative. So that'll make both of these a positive, right? Negative, 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 negative. Right? Now let's do it. Subtract. Negative 32x squared minus negative 32x squared would be 0. 20x minus negative 40x, that'd be 20x plus 40x. So positive 60x. Right. And then negative 3 minus nothing is negative 3. Right. So basically, again, the terms that aren't used just drop down. Alright, so after subtraction, we have 60x minus 3. That's a degree 1 polynomial, x to the first. Right? The divisor is also degree 1, so we're not done. We repeat these steps until the degree after subtraction is less than the degree of the divisor. Right now they're equal. They're both degree 1. So I go one more time. Right, the division step. The lead term here is 60x divided by the lead term of the divisor, 4x. 60x divided by 4x would be positive 15. So that's the next term I write in the quotient. And then we do the multiplication step. Take 15, multiply it by the divisor. 15 times 4x plus 5. Do each term. 15 times 4x is 60x, and 15 times 5 is 75, positive 75. Okay. Now I did the division step, the multiplication step, now the subtraction. Don't forget to subtract all of it. Put a minus sign and then parentheses around that line you wrote. We're going to subtract 60x and subtract 75. 60x minus 60x is 0. Negative 3 minus 75 would be negative 78. Right. And now we're finished. A constant is all that's remaining, negative 78. That's degree 0. A constant is degree 0. And this divisor is degree 1. So the degree after subtraction is less than the degree of the divisor. So we are finished. Alright, so the quotient was 4x squared minus 8x plus 15. And then this result after subtraction, when the degree is less than the degree of the divisor, when you finish the division process, this negative 78 would be called the remainder. Okay, so how do we write the result of division? Right, here's how. And I'll come back to this, obviously. But when you take dividend divided by divisor, here's how, as a fraction, here's how you write the result. You write the quotient, right? Tell me how many times does the divisor go into the dividend, and then you add a fraction. Right? There's a fraction left over. There's some remainder left over, and it's the remainder over the divisor. Right. So this is huge, right? This is the way we're going to write the result of our division problems. And if this looks unfamiliar to you, for example, if I had like 11 divided by 7, right? 7 goes into 11 once, with 4 left over, so you would say that this is 1 4/7. Right? The quotient's 1, the remainder would be 4, and you still have this divisor, 7 here. It's 1 4/7. That's just one quick example with numbers. Now, if you were to take this equation I wrote up here, if you were to multiply everything on both sides by the divisor, if I was to multiply both sides by the divisor, we'd get the following. We'd have the dividend equals the quotient, if I multiply by the divisor, on the left side the divisor cancels, I'm left with the dividend. On the right side I multiply both of these terms by the divisor, so we'd have the quotient times the divisor plus, and then this fraction here, if I multiply this by the divisors cancel and I'm left with the remainder. Alright, so here's another way we could express the result of our division. In fact, this is the way I'm going to use to check our result. Alright, I'm going to use this version to check and see if we are correct. Alright. So for this particular example, when I did all this, we have the dividend is this degree 3 polynomial, the divisor is this degree 1, we have the quotient is this degree 2, and the remainder is this constant. For this example, we can write the following. We can say that 16x cubed, so 16x cubed minus 12x squared plus 20x minus 3 divided by 4x plus 5, that fraction there is equivalent to the following expression. The quotient, 4x squared minus 8x plus 15, plus the remainder over the divisor. Now the remainder is a negative number, so I can go minus 78 over 4x plus 5. Alright, this is because I wrote plus the remainder over the divisor, but the remainder was negative. Okay. So here's the result of our division. Or, and this is the one I'll actually use to check, if I multiplied both sides here by 4x plus 5, we'd have the following. The dividend, 16x cubed, minus 12x squared, plus 20x minus 3, should be equal to the quotient times the divisor, 4x squared minus 8x plus 15 times 4x plus 5, both in parentheses, quotient times divisor, plus remainder, just minus 78 or plus negative 78. Let's check it. So I'm going to take this side here and actually multiply it out. And if I multiply this stuff out and combine like terms, we better get the dividend back. If this is true, if these are truly equal. Alright, so remember how to multiply polynomials, right? First I'm going to multiply these two, and then we're going to add negative 78. So I'll take, when you multiply two polynomials, right, you take every term from one of them and distribute to the other. So I'll take these 4x and 5 here and distribute to the three terms there, the 4x squared minus 8x plus 15. Alright, so 4x distributed is 16x cubed minus 32x squared and then plus 60x. All right, that now I'm done with the 4x. Now I'll move over and distribute the 5 to these three. Be plus 20x squared, and then minus 40x, and then plus 75, and then now I'm done multiplying, and then don't forget the minus 78 at the end, right, the remainder. And then combining like terms, we get 16x cubed minus 12x squared plus 20x, and then 75 minus 78 is minus 3, and look at that, it's exactly the same as the dividend. So this quotient, this divisor, this remainder, the quotient and remainder that we got are correct. Or at least it looks that way. Now something else you could do to verify that these truly are equal, right, the result of the division is correct, is go to a calculator and graph them. Now I know we've only seen graphs of polynomials up to this point, polynomial functions in chapter 5 of this text, but well, I guess you could also just graph this too, just to make sure that the thing's real. All right. So I mean, yeah, let's do that. Let's graph the polynomials, and not, we'll get to later in chapter 5 graphs of rational functions. So maybe I'll talk more about this stuff later, but so I'll take you to that. There's a free online graphing calculator at desmos.com. And the first function I'll put in is y equals the dividend, right? 16x cubed minus 12x squared plus 20x minus 3. All right, so I get this degree 3 polynomial. I mean, I know you're not seeing a lot of it. It's just this, red strip here. There's obviously much more to it, but now the other function I'll graph is the quotient, right? The quotient we got, y equals 4x squared minus 8x plus 15 times the divisor, right, which was 4x plus 5, and then after the quotient times divisor plus the remainder, which was negative 78. And you see how it's exactly the same graph, right? Red, blue here, or whatever colors you're seeing. But it's right on top of the other graph, right? They're the same graph. So the quotient times the divisor plus the remainder is equivalent to the dividend. At least it looks that way from the Desmos site. Right? And if you look at some tables, they'll have the exact same value. And if I make a table for both of these, you'll see that they have the exact same values for the same inputs. Right, see, when x is negative 2, both of these expressions have a value of negative 219. When x is 0, both expressions have a value of negative 3, and so on. Right. But we don't need all this. Great. Alright, so that was a lot. But the steps, I'm going to be doing the same steps every single time. You set up the division, divide lead terms, multiply by divisor, subtract. And then you keep repeating these 3 steps over and over again until the degree after subtraction is less than the degree of the divisor. And then if you want to check, take the quotient times the divisor and then add the remainder, and you should get the dividend, right, as I stated here. Right? Both of these are the same equation, basically. Right? Both of these are the way you can express the result of a division problem. Okay. All right. So yeah, I'm going to be doing that the rest of the video. Right. Next example. They're asking us to divide, right? Division symbol. So again, the dividend is 2x squared minus 9x minus 5. And the divisor is this x minus 5. Please understand that the divisor is not always going to be a binomial. It's not always going to be a degree 1 polynomial, right? You know, the last example, the divisor was 4x plus 5. Here it's x minus 5. Both of them are degree 1s. The divisor can be any polynomial. Okay, not just a degree 1 binomial. Please understand this. Alright, so I set up the division. There's the long division symbol. And inside goes the numerator, or the dividend, in descending order, 2x squared minus 9x minus 5. Right. Then outside on the left here, the divisor, again in descending order, x minus 5. Alright, so the first step is divide the lead terms. 2x squared divided by x. That would be 2x. And I write that in the quotient area. Then we multiply by the divisor. 2x times x minus 5 would be 2x squared minus 10x. Right? I'm lining up like terms here. Then we subtract that entire line from the line above it. 2x squared minus 2x squared is 0. Negative 9x minus negative 10x would be plus 10x. Negative 9x plus 10x, that'd be positive 1x. And then negative 5 minus nothing would be negative 5. Alright, and then the degree after subtraction is 1. The degree of the divisor is also 1, so we're not done yet. So I start over. Divide the lead terms. X divided by x is positive 1. So I write plus 1 in the quotient. Then we multiply. Take the positive 1, multiply by the divisor. Now 1 times anything is itself, so this is just x minus 5. And then we subtract that entire line from the line above it. Now x minus x is 0. Negative 5 minus negative 5 would be negative 5 plus 5. That would also be 0. So all I'm left with is 0. Now, one note to point out here is when the remainder is 0, that means something. It means something special. When the remainder is 0, that means the divisor and the quotient are factors of the dividend. The divisor and the quotient, both go into the dividend evenly. There is no remainder. So that means they are factors of the dividend. Right? In other words, the dividend, right, is like earlier. We're going to say it's equal to the quotient times the divisor plus the remainder, but the remainder is 0. So I don't need to write that. So you can see how we can now factor the dividend as the quotient times the divisor. Alright, so again, the result of this you can write in two different ways. You can say that this is equal to just 2x plus 1. Right? This is the same thing as 2x squared minus 9x minus 5 divided by x minus 5. Just say it's equal to the quotient, 2x plus 1, plus the remainder over the divisor, right? Which would just be 0. 0 over x minus 5. This is 0. Or, multiplying by the divisor, we have 2x squared minus 9x minus 5 equals, the quotient times the divisor. And I leave it to you to check that, right? Check. Oh, you can do it pretty quickly, actually. 2x squared and minus 10x plus 1x would be minus 9x and then minus 5. They are equal. Right. And if you want to look at graphs of the two expressions as functions, polynomial functions, and see that they're the exact same graph, you can do that too. But I'll leave that to you though. I'm not going to go back to Desmos anymore. But this is key. This is another important note. Something we're going to keep an eye out for whenever you divide. If the remainder is 0, that means that the dividend can be factored. Okay. And yeah, like more of the same. Again, every example in the book has a degree 1 polynomial as a divisor. I'll say this every time, or at least a couple more times. The divisor can be any degree, as long as it's less than the degree of the dividend. If the divisor has a degree greater than the dividend, then there's no quotient. Right? The quotient would be 0. Alright, so once again, same setup. This time the dividend is this polynomial, 4x squared minus 10x plus 6. The divisor on the outside on the left here, 4x plus 2. And the same 3 steps. Divide the lead terms. 4x squared divided by 4x would just be 1x. That goes in the quotient. Multiply by the divisor. X times 4x plus 2 would be 4x squared plus 2x. Then subtract this entire line from the line above it. 4x squared minus 4x squared is nothing. Negative 10x minus 2x is negative 12x. And then 6 minus nothing is 6. Plus 6. This is degree 1. The divisor is degree 1, so it's not less yet. So we keep going. Divide the lead terms. Negative 12x divided by 4x would be negative 3. That goes in the quotient. Then I multiply negative 3 by 4x plus 2. That'd be negative 12x minus 6. And then subtract this entire line from the line above it. Negative 12x plus 12x would be 0. And then 6 minus negative 6 would be 6 plus 6. That would be positive 12. So the remainder is 12, right? That's not 0. So that means that, this quotient and divisor are not factors of the dividend. So we have 4x squared minus 10x plus 6 divided by 4x plus 2 is equal to the, remember, dividend divided by divisor equals quotient, x minus 3, plus the remainder over the divisor, 12 over 4x plus 2. Or, and if you multiply everything by the divisor, you'll have 4x squared minus 10x plus 6 equals the quotient, x minus 3, times the divisor, 4x plus 2, plus the remainder, right, plus 12. And again, I can check this out loud pretty easily. Let's take the quotient, multiply by the divisor, and then add the remainder and see if we get the dividend. So if we multiply the quotient and divisor, you get 4x squared, cool, plus 2x minus 12x for the minus 10x, great. And then you have minus 6, but then you're adding the 12 later for the plus 6. Excellent. So that is correct. The quotient times the divisor plus the remainder is indeed equal to the dividend. All right. Just got a few more of these. They're all the same, really. Now this next couple of examples See how the dividend doesn't have certain terms? Like it has an x squared term, but it doesn't have an x to the first term. Now, you don't have to do what I do here, but I'd recommend it, just to make sure you're keeping track of all the terms, fairly easily. So the dividend is, negative x squared is the lead term. Then you have no x to the first term, so I like to put that in there, even though it's not there, plus 0x. Again, you don't have to write this, but I find it easier to keep, like terms lined up and whatnot if you take into account every term below the lead term. So negative x squared, there's no x to the first, and then you have minus 1 for the constant, right? So here's the dividend. And once again, the divisor is a degree 1. I'll say it again, the divisor doesn't have to be a degree 1 polynomial. Right? Just know that you may come across examples in other books in the future like that. Alright, so putting it in descending order, x plus 1 out here. Alright, so now that I've set up the division, I do the same 3 steps over and over again. First, I divide the lead terms. Negative x squared divided by positive x would be negative x. That goes in the quotient. Then I multiply by the divisor. Negative x times x plus 1 would be negative x squared. And then minus x. Again, I put that under the 0x here. See, I like having the 0x because it helps me avoid confusion. If I just put the minus 1, I might think that those go together even though they don't, right? They're not like terms. Then the subtraction. We subtract this entire line I just wrote from the line above it. So negative x squared minus negative x squared would be plus x squared, that's 0. 0x minus negative 1x would be plus 1x. 0x plus 1x is 1x. And then negative 1 minus nothing, negative 1. Right. This is degree 1. The divisor is degree 1. It's not less than yet. So I keep going. Divide the lead terms. X divided by x would be positive 1. So that goes in the quotient. 1 times x plus 1 would be x plus 1. And we subtract that entire line from the line above it. X minus x is 0. Negative 1 minus 1, negative 2. And now that's degree 0. The divisor is degree 1. I can stop. So negative 2 is the remainder. So we'd say this. Negative x squared minus 1 divided by x plus 1 is equal to negative x plus 1, right, the quotient, plus the remainder over the divisor, so minus 2 over x plus 1. Again, I'm only putting a minus here because the remainder was a negative number. Or, again, taking this expression here, or this equation here, and multiplying through by x plus 1, multiply everything by the divisor, we say the following. Negative x squared minus 1 should be equal to the the dividend is equal to the quotient, negative x plus 1, times the divisor, x plus 1, and then plus the remainder, minus 2. Alright, well, negative x plus 1 times x, again, you check this. This would end up being just 1 minus x squared, or negative x squared plus 1, and then minus 2 would make it negative x squared minus 1. That works. So this quotient, this remainder are correct. Great. Alright, looks like I got just 2 more examples. Just 2 more. Alright, so here I have a degree 3 divided by, again, the divisor is a degree 1, but it doesn't have to be. It's just for some reason in this book that I'm going through all the examples, the divisor is degree 1. Okay. So again, the dividend is x cubed Now you can write minus 126 if you wish, nothing wrong with that. Again, I personally just like throwing in the zeros. You know, there's no x squared term, so plus 0x squared. There's no x to the first term, right? So plus 0x, and then the minus 126, right? Again, the only reason I do that is to help avoid confusion later when I'm lining up like terms and whatnot. And then out here, the divisor in descending order, x minus 5. And the same steps. I divide the lead terms, which would be x squared. I multiply by the divisor, that'll give me x cubed minus 5x squared. Subtract that entire line from the line above it. That'll give me positive 5x squared, plus 0x minus 126. Then I start over. 5x squared divided by x is positive 5x. Multiply the positive 5x by the divisor, giving me 5x squared minus 25x. But then you're subtracting that entire line from the line above it, giving me positive 25x, right? 0 minus negative 25, and minus 126. And then on one more step here. 25x divided by x is positive 25. And then multiply the 25 by x minus 5. That's 25x. And then 25 times negative 5 would be negative 125. And subtract that whole line from the line above it. Now negative 126 plus 125 would be negative 1. Alright, so the remainder is negative 1. The quotient is x squared plus 5x plus 25. The remainder is negative 1. Alright, so again, the couple ways we could write this, we could say x cubed minus 126 divided by x minus 5 is equal to x squared plus 5x plus 25, and then minus 1 over x minus 5, right? It's a quotient plus remainder over divisor when you have it as a fraction. Or if you multiply through by x minus 5, multiply everything by the divisor, the dividend x cubed minus 126 should be equal to the quotient times the divisor plus the remainder afterwards. And this is true because when you multiply the quotient and divisor, you'd end up with x cubed minus 125, and then you'd have minus 1 for the minus 126. So this checks out. The quotient and divisor and remainder, the quotient and remainder I got are good. All right, and one last example. It's all the same steps every single time. But again, their divisor is another degree 1 binomial. It's not going to be a degree 1 binomial all the time. Right. But just for some reason in this text, this OpenStax algebra and trigonometry text, when they're showing you all these examples, having you do these exercises, their divisor is a degree 1 every single time. Just please understand that it doesn't have to be, but you would still do the same steps that I've been doing here. Alright, so I set up the division. Again, now the dividend has, this x cubed minus 3x squared plus 5x minus 6. Divisor is x minus 2. Alright, so first step, divide the lead terms. X cubed divided by x is x squared. Multiply by the divisor, we get x cubed minus 2x squared. Subtract that entire line from the line above it. You get no x cubed now, and then negative 3x squared plus 2x squared would be negative 1x squared. And then you got positive 5x minus 6 still. Right. Start over, divide the lead terms. Negative x squared divided by x would be negative x. Multiply negative x by the divisor, get negative x squared plus 2x. Then subtract all these terms from the line above it. 5x minus 2x is 3x, and you still got the minus 6 here. And then one last time it should be divide 3x by x, you get positive 3. Then multiply the positive 3 by x minus 2, that's 3x minus 6. And hey, look at that, the remainder is 0. The remainder is 0. So that tells me, again, when the remainder is 0, that tells me that the divisor and the quotient are factors of the dividend. And once again, the two different ways to express this division problem are this. We have x cubed minus 3x squared plus 5x minus 6, divided by x minus 2 is equivalent to x squared minus x plus 3 and then plus 0 over x minus 2, but that's just 0. Or, multiplying both sides by x minus 2, we have the dividend is equal to the quotient times the divisor. Right. And again, you can check this on your own. Distribute the x, distribute the negative 2. You should get the same terms. It should be the same. All right. Now I hope you see where this is going. In an earlier chapter we talked about factoring polynomials, and usually when there was a degree 3 polynomial like this with 4 terms, we tried to factor it by grouping. But you'll find out, practice on this, try this. If you tried factoring x cubed minus 3x squared plus 5x minus 6 by grouping, you wouldn't get anywhere. But yet we were still able to factor it. All right. So what's the key here is going to be trying to find a divisor that'll give me a remainder of 0. Now, we're going to get into how we do this in later videos, but just understand that, later in this course, later in these chapters, in this text, we're going to take a polynomial that's degree 3, degree 4, degree 5, whatever, and we're going to be able to figure out how to factor it, with methods that we haven't seen yet. But it's going to involve the fact that the remainder is 0 upon division. Great. Alright, so I'm hoping that watching me go through these 6 examples here help you in some way when you're asked to perform polynomial long division on your own. And thank you very much for watching.